Okay, this is the last problem in this series on the topic of linear momentum. So in this, we have a shell which explodes into two pieces. The difference is that this time the shell itself is initially moving on a frictionless surface, and then it explodes and splits into two pieces, two parts. The question says that there are two parts. The shell splits into two parts. One is 4 kilogram part, another one is a 6 kilogram one. And the 4 kilogram one moves in a direction 4 meter per second, moves with 4 meter per second velocity in the north direction, and the 6 kilogram part moves with 7 meter per second in the west direction. And we are required to find the velocity of the original shell. So we can take this shell and its two pieces as an isolated system, which means that the principle of conservation of momentum is applicable to this situation. So as per, let me write here as well, as per principle of conservation of momentum, total momentum before explosion is equals to total momentum after explosion. I can write this as TMBE and that one as TMAE. Right, so all we need to do is we need to find the total momentum after explosion. So let's do this. Total momentum after explosion consists of two pieces. So let me say that piece 1 has a momentum P1, and we already know that momentum is m times v. So this is 4 kilogram times 4 meter per second, and because velocity has direction due north, so that will be also be due. That will also be due north. So this is 16 seconds Newton due north, and P2 is the momentum of the second piece, and this is mass is 6 kilogram and velocity is 7, and this is due west. So basically we get, sorry, I wrote 4 here, it should be 7. 6 times 7 is 42 second Newton due west. Now we need to find the total momentum. So total momentum after explosion is addition of these two vectors here, these two momenta here. So we need to find P1 plus P2. I'll put these arrows here to indicate that we are looking for the vector addition of these two momenta. So vector addition is, we are now quite familiar with this. So first one is 16 seconds Newton north. So I'll draw the diagram like this. That's 16. And the second one is 42 seconds Newton due west. So this is my 42, and my total momentum is this. So I will find that angle as well. So this is the length of my P1 plus P2 vector. So P1 plus P2 I can write like this, and if I want to be very particular, I will say that I'm just talking about the length here, magnitude of the vector. So that will be as per Pythagoras theorem, because this angle is 90 degree. 42 square plus 16 square, and that gives me 44.94 second Newton. Now I also need to find the angle here. So from this triangle we can see that tan theta is equals to opposite over adjacent. So tan theta is equals to 42 over 16. That gave you theta is equals to tan inverse 42 over 16, and plugging these things in calculator, I'll get an angle of 69 degree and 69.15 degree. Therefore, the total momentum after explosion is equals to P1 plus P2, and I can do this, is 44.94 seconds Newton, and the direction we can see that it is from north towards the west. So from north towards west. This is the total momentum after explosion. Now this momentum should be equal to total momentum before explosion, right? So before explosion we have only one piece, so total momentum before explosion is equals to our object is 10 kilograms. The shell is 10 kilogram because it's split into 4 and 6 here. So 10 times v, where v is the velocity that we need to find. So I'll just call it a v there. All right. So as per this principle of conservation of momentum, these two momenta should be equal. So I will say tan v is equals to 44.94 seconds Newton due north 69.15 degree west, and that will give me, dividing by 10 on both sides, I will get 4.49 meter per second, and the direction is north 69.15 degrees west, and this is the velocity that I was looking for.